Hello everyone, this is Siddharth, and in this video we will be solving another question from the list that I have shared in the starting of this playlist. So if you don't know what we are doing here, we are solving all those questions which are related to each other so that we can able to build pattern and able to memorize all those standard processes and methods so that we can use them in the upcoming question and the interview as well and able to solve them very easily. So let's start with this question, which is sentence similarity 3. So in this question, what we have to do, we have to check whether the smallest string that we have given is the substring of the second one or not, which is obviously greater than the first one. And what additional condition is there, we can remove some words also from the longer string and make them equal to the first string. If that is possible, then we can return true, otherwise we have to return false. So let's see how we will be solving this question. Obviously, we will be using two pointer here as well. Now I will suggest that you can go and pause the video and then try to solve this as well using two pointer approach. Now let's try to move on to the blackboard so that we can understand this. So let me connect this first. Sorry for this. Okay, so these are the two strings that we have given. Hello Jane. So hello, then Jane, and another string. This is S1, and then S2 is hello, my name is Jane. So hello, my name is Zane. So obviously we can remove this and then we can make this above string equals to the first one. So we can return true here. So this is what we have to do. Now what we can do, we can split these both of these string. So we can convert these given sentences into an array of strings. So hello and then Jane, we can split them, and the second one will look like hello, then my, and then name, and then is, and then Zane. So we will start our pointer from here, and we will compare these two. So obviously they are equal, so we will move on to the next word, and now they are not equal, so we have to we don't have to check now. Yeah, we can start checking from the right as well. So Zane is equals to Jane, so our right will become here. So currently right is pointing in the start, right is pointing to 0 because we will be pointing right and left in the 0 as well. But we want to return the length of this remaining array so that we can remove them. So that's why we are pointing this right to 0 as well. Now after encountering the same word from the right side, we can increment the right value. So right will become 1 now and left will become 1 now. So the length of right plus left, is equals to 2, and the left length of this as well is 2. So what does it what we can understand from it, or what does it specify, that we this is the continuous sub array of this second longer string. So we can return true here. So that's what we have to check in the return statement. If the value of this right plus left is greater than or equals to the uh, value of n1, which is the smaller string, and we will keep track of that we will be passing array 1 as the smaller. You will soon know how we can do that. So we just have to check for this, that this the smaller array we will be passing first, and we will be checking if this is the continuous subarray of the longer string. For that we are defining two pointers, and then we are moving them from the left and right, and then we will be calculating the length of the remaining subarray. And if that is greater than equals to the first array, then obviously it means that this is the continuous subarray of the longer string. So we can return true, otherwise we have to return false. So now let's try to solve this as well. So first we have to convert these sentences into string. So for that we can use like this. So string let's use name it as array1 is equals to sentence 1 dot split. So it will split on the base of space and convert that into array. And then let's define string 2 as well. So copy paste. So let me, okay, so this will going to be array 2 and we will be splitting array sentence second. And now we have to keep we have to check that we are passing array 1 as the smaller one. So for that we can apply in if condition, if array 1 dot length, array 1 dot length uh, is equals to array 2 dot length. If this is the case, then we have to just, as array 1 is greater, so we have to pass array 2 first. So we can use r sentence, or let me copy paste this. So r sentence similar, we will be calling this and passing sentence 2 as it is smaller. So sentence 2 and then sentence 1. So this ensures that the first array that we are calculating is always smaller. So, and we have to return this as well, as we have to return the boolean as the data type. Now we can move on to solving this question. For that we have to make two pointers. So start will be pointing to 0, and then right left, or we can say end, is also pointing to 0, and then we have to calculate the length of the first and second array. So n1 will equals to array 1 dot length, and then n2 is equals to array 2 dot length. Now we just have to do the same thing that we have done, like we are doing in the almost all the video, using two pointer approach. So while uh, what we have to do, we have to move from the left and right side. So we can do like that. So while the word which is at the first index, that will going to be hello, if that is equal, so we can do like that. So if the start value is less than the value of n1, uh, and another condition will going to be, so this we are checking so that the start pointer will not exceeding the length of the n2 n1, that is small string. So now we can, otherwise index out of bound error will come, and this array 1, the element which is at the position of the start should be equals to or we can use equals to array 2, the element which is present at the starting index of the array 2. So if these two are equal, which is in this case, then we have to move our left pointer. So we can use left, or we can say start plus plus, sorry, start plus plus, and we have to do check for the from the right hand side, or we can say suffix. So this will going to be right. So right should also be less than n1, and array 1 start, and this will going to be n1 minus 1 minus start. So why we are doing this, let me tell you, because we have to check from the right side. So we have to check from the last word. So we can do like that, n1 minus 1 will point to the last index of the first array, and then minus right we are minus right we are doing, let me do this as, so rigst, so minus right we are doing so that we can move inward into the array from the right side. That's what we have to do, so that we can use check for the suffix, and this is what we have to do here as well. So n2 minus right, sorry, n2 minus 1 minus right, so this will do the same, and then we have to increment the right counter, so right plus plus. And after checking for this, we have to return what we have to return, we have to return true or false. For that we can check that the start plus end should be greater than or equals to n1. Only then we can say that the s1 is the continuous subarray of the second one. Otherwise, if the subarray is already, like the common part that we are getting is even smaller than the first one, then how we can say that it is in subarray. That's why we are doing like this, and then we can try to run this. Okay, so this should be, sorry for this should be end, and this should be end as well, and this should be end, and here as well. Okay, now let's try to run. Okay, now let's try to submit this as well. Okay, so it is taking time because of the. Okay, so we have successfully solved this question. See you in the next video. Bye.